For over 100 years, Spirax Sarco has been the world leader in steam engineering, developing and providing customers with ways to improve the performance of their plant and processes. Even with today's modern manufacturing methods, the best way of transporting heat energy successfully continues to be steam. Steam offers efficiency and flexibility for industrial processes and heating. It is highly cost-effective, and its temperature and pressure can be easily and accurately controlled, which is why process industries continue to favor it as their heating medium. Steam is used in the production of the food you eat and the medicines you take. Steam is used to provide a comfortable living environment with hot water, and due to its sterile nature, is used to humidify air conditioning in hotels, hospitals, commercial and institutional buildings. It is also used to help produce the clothes you wear. In fact, it's all around us. Most of the products you use, wear, drive, eat and drink every day have relied upon steam at some stage in their production process. For steam systems to work efficiently, steam needs to arrive at the point of use in the correct quantity and quality. It must be at the right pressure and temperature, dry and free of air and other gases. Close attention to pipework design and layout is critical if these requirements are to be met. In addition, careful selection of steam trapping and air venting will remove unwanted gases and condensate in the distribution system, as well as on the steam-using plant. Steam traps are designed to remove the condensate, which forms as heat is given up by the steam, typically through pipework or during a heat exchange process. They do this automatically, differentiating between condensate and steam, allowing unwanted condensate to pass, whilst holding back the steam in the system. The consequences of getting it wrong can be dramatic, with many causes of failure in process systems attributed to poor condensate drainage and removal. Selecting the correct steam trap is therefore essential, especially when you consider some of the extreme conditions they are expected to operate under. It is for these reasons, and the experience built up over years with our customers, that Spirax Sarco believe there is no such thing as a universal steam trap, that no one type fits all. We also believe we are best placed to ensure you select the most efficient steam trap for your application from a very comprehensive range. A number of operating principles are used in trap design, and here we are going to look at how they work, the fundamental differences, and why some are more suitable than others depending upon the application. Let's look at mechanical traps. Mechanical traps all sense the difference in density between steam and condensate. Common examples are float and inverted bucket traps. With the float thermostatic type, as condensate reaches the trap, it raises the float and opens the valve, immediately discharging the condensate. As the level of condensate falls, the valve closes, thereby holding back the steam. Large volumes of air occurring on startup or during running will be discharged through the separate internal air vent. Notice that at all times the valve and seat are immersed in condensate, ensuring an effective seal. The Spirax Sarco float thermostatic range is the most advanced in the world. Constant design improvements have made the traps extremely robust and features include self-aligning main valves and horizontal as well as vertical connections. The inverted bucket type of trap relies on a water seal, which is formed as condensate reaches it. At startup, the weight of the bucket keeps the valve off its seat, and condensate flows around the bottom of the bucket and out of the top. As steam enters the underside of the bucket, it creates buoyancy, lifting the lever mechanism and snapping the valve shut. The valve opens again when buoyancy is lost due to steam leaking through the small bleed hole in the top of the bucket. Whilst this trap type is robust, it does not handle air well. When used on superheated steam, the essential water seal can be lost due to sudden changes in pressure. A variation in the float type is the free float trap, which, as the name implies, uses no lever arm mechanism. Condensate entering the trap raises the ball off its seat and allows condensate to flow. As the flow rate falls, the float will settle back upon the seat positioned by the guides. An internal thermostatic valve allows air to vent from the trap. Roundness of the ball float is critical to ensure a tight shutoff under low or no flow conditions. Damage from dirt or water hammer can distort the ball, leading to live steam leakage. Having no lever arm mechanism limits the trap's capacity for any given differential pressure, so care should be taken during selection and sizing. Some manufacturers compensate for this by only quoting for cold or sub-cooled condensate capacities, which can be misleading. The second operating principle is the thermodynamic or disc type. For very good reasons, these are by far the most popular type in the world and rely on the difference in velocity between flash steam and condensate to operate. On startup, low incoming pressure in the inlet acts on the underside of the disc, raising it and allowing air and cool condensate to be discharged. When condensate approaching steam temperature enters the control chamber, the drop in pressure produces flash steam with a corresponding increase in its velocity. This creates a low pressure area under the disc, which is drawn towards the seat. Simultaneously, a pressure build-up of flash steam in the chamber, acting over the large area of the disc, overcomes the inlet pressure, closing the valve with a very clean and crisp action. The trap opens again when the flash steam trapped above the disc condenses and is overcome by the inlet pressure. Bear in mind that the trap's action is entirely due to energy created from flash steam, and no live steam is used in its operation. Thermodynamic traps are compact and have one moving part, which makes them extremely rugged, providing years of reliable, trouble-free service. Our third group operate by being able to sense the difference in temperature between steam and condensate. There are two fundamentally different types, balanced pressure or capsule traps, and bimetallic thermostatic models. A balanced pressure trap has a stainless steel capsule at its heart, filled with a deionized water and alcohol mixture. On startup, cold air and condensate enter the trap and are readily discharged through the open valve. As the capsule warms up, its liquid boils and the resultant pressure on the diaphragm pushes the valve head towards the seat, fully closing before any steam is lost. As the condensate within the trap cools, the valve reopens, discharging condensate. Balanced pressure traps clear air and cold condensate rapidly on startup and are unaffected by back pressure. By the nature of their operating principle, they subcool condensate, making use of the sensible heat before discharge, thereby saving energy. Looking at traps that use the bimetallic principle, on startup the bimetallic element is relaxed, allowing cold condensate and any air to be freely discharged. When hot condensate flows through the trap, it heats the element, causing the valve to pull towards the seat. As the hot condensate is discharged, the bimetallic element closes the valve. As the element cools, the upstream pressure opens the valve and condensate is once again discharged. On lightly loaded applications, thermostatic traps do not actually cycle, but take up a position where condensate is discharged constantly at the predetermined subcooled temperature. The robust bimetallic principle is often used for high-pressure applications. It is important to note that the valves are invariably positioned on the downstream side of the seat, where any unusually high back pressure will result in lower discharge temperatures. From time to time, fixed orifices are promoted as a universal panacea. But as we have shown, the varying conditions that traps have to work under make such a device highly dubious. From the earliest time, it was recognized that a variable orifice, perhaps a simple gate valve, was necessary in order to either open the flow to cope with an increase in condensate load or to throttle the valve to avoid loss of live steam. Automatic steam traps remove the need for manual intervention that clearly fixed orifice devices cannot do. Experience suggests that the selection is one of compromise between an orifice too small for startup conditions and too large for the running load. In practice, the orifice is often so small and so easily blocked with dirt and pipe scale that their use increases the risk of water hammer. Unless you are certain you have absolutely clean and constant conditions on your plant, fixed orifice devices are best avoided. Most manufacturers agree, due to the different conditions under which a steam trap works, there can be no single solution. Choosing the correct steam trap for your application will result in a more efficient process and give long and trouble-free service. So, where do each of these types of trap fit into a real steam system? For a mains drainage application, a thermodynamic trap would be recommended, as there are often long runs of pipework with risk of water hammer on startup. These traps are small, tough and very reliable, and are able to withstand water hammer and freezing. In cases where startup is a daily routine, you may find that strategically placed air vents are necessary to clear air more quickly. Where control of temperature is critical in product tracer lines, a thermodynamic trap will remove condensate as soon as it's formed. Where temperature variation is acceptable, then a degree of subcooling provided by a balanced pressure thermostatic trap will ensure the use of some of the sensible heat in the condensate before discharge. Ball float traps should be the first choice for all process heat exchange applications, including heater batteries, air coils and calorifiers. The processes all rely upon the rapid removal of condensate to provide maximum heat output. Float thermostatic traps are unaffected by variations in load or pressure, which can often drop to sub-atmospheric vacuum conditions. For the same reasons, ball float traps are also the first choice for use on steam separators. Bulk storage tanks are often used for storing oils and chemicals and have large grids of horizontal heating coils which can suffer from water hammer. In these cases, the first choice would be an inverted bucket trap, which is robust enough to be able to withstand these effects. Since startup is infrequent, the trap's inability to deal quickly with large amounts of air is not critical. For high-pressure superheated steam applications, such as mainline or turbine drainage, a bimetallic thermostatic trap is a suitable choice. This trap is wide open on startup and is able to vent large quantities of air and cold condensate, whilst being able to withstand the extremely high temperatures. These are just a few examples of where a carefully selected and sized steam trap can provide optimum performance. Steam traps are an integral part of any steam system, and by understanding their function and application, they should work as well as any other item of steam plant. To ensure your steam traps are working effectively, a degree of maintenance is always necessary. Identifying trap performance can be done using a variety of methods, including ultrasonic leak detection or Spirax Sarco's own inbuilt or remote Spiratech system. This enables you to easily determine if a trap is in need of attention. But with changing practices, more companies are moving towards outsourcing of services. Spirax Sarco are able to offer complete on-site service, from steam trap surveys and steam system audits, right through to the replacement and maintenance of the installed steam trap base. Spirax Sarco has teams of specialist engineers, expert in steam trap performance monitoring and maintenance. We can provide site surveys, and with our steam trap maintenance software program, STMS, we are able to manage your installed base on your behalf. We will even provide justification for capital expenditure. This can be illustrated using a financial model designed to determine the reduction in the total cost of ownership of your steam trap installation using the latest trap technology. At Spirax Sarco, we can provide reduced cost of ownership for our customers the world over through innovations such as steam traps with quick fit or 2-bolt technology for reducing maintenance costs. We also produce products for very specialized industries such as biotechnology and pharmaceutical. Our worldwide network of 800 direct sales engineers will provide you with technical training, support and solution, not to mention our excellent website at www.spiraxsarco.com. Our dedicated manufacturing facilities and expertise generated from years of industry exposure ensure excellent product quality and production standards. With no universal steam trap, careful selection, accurate sizing and installation are all important factors. By choosing Spirax Sarco, we will ensure your steam system runs efficiently and safely. With regular inspection and testing, we can reduce the total cost of ownership of your system, ensuring it provides reliable service and remains a valuable asset to your company. Steam traps are a vital part of your steam system, without which it cannot function correctly. So, by choosing Spirax Sarco, you know you are getting superior customer service commitment and high-quality products designed and manufactured by the industry leaders.